All right, now let's get into the first set of problems, which is going to be graphing. Again, remember, I'm creating this video really to kind of create a answer sheet, so I'm going to talk my way through it. But if you need some more step-by-step instruction of how I am doing these, then go ahead and check out the additional training videos that I have that accompanies this practice worksheet. So I'm going to work through, rather quickly. I will explain my stuff that I'm doing, but again, if you aren't understanding what I'm doing, you need a little more details, then check out the quick review videos I have that accompany this. So I'm going to kind of work through these because I really just need an answer sheet to kind of work with. So the first thing is going to sketch the graph, identify the domain and range. The main thing I see here is I have a negative on the outside. That means I'm going to reflect the parent graph about the x-axis. So instead of having my parent graph look like this, which will be the only time I'll create my parent graph here, remember we have a horizontal asymptote going right there. So I'm just going to reflect that about the y-axis. So now my graph will look like this. It's still going to be approaching that horizontal asymptote right there. I'm going to delete the parent graph, just so I wanted to graph it at least once so you guys could see it, just as a quick reminder. And then now we just need to identify what the domain and range is going to be. So the y-intercept is now going to be 0, -1. My domain, though, is still going to be all real numbers. That's not going to be impacted. And my range, though, is now going to go down to -infinity and go all the way up to 0. But again, 0 is not included because that's a horizontal asymptote. All right, the next one here is I have 2. So that's going to change my new y-intercept. Whenever you're multiplying by a number on the outside, that's going to change my new y-intercept to be at 2, 0 instead of 1, 0. And then I have not only a reflection about the x-axis, but now I have a reflection about the y-axis. So none of these transformations are affecting my horizontal asymptote. So this graph is going to look something like that. My domain is not going to be impacted, and my range is actually not going to be impacted from the original parent graph. So my domain would be -infinity to infinity, and my range here is going to be 0 to +infinity. All right, look at the next one. Again, don't get concerned about the base here, ladies and gentlemen. That's going to impact your graph if it's 2 or if it's 10, but it's not going to impact my domain and my range. So this parent graph, the y equals, e to the x, is still going to have a y-intercept at 0, 1, and it's still going to have a horizontal asymptote at y equals 0. However, now we need to apply our transformations. So what I'm going to do is just use this as red. So I'm going to go left 1, and then from here I need to go down 2. What's also important that's moving down to is going to be my horizontal asymptote, right? Originally it was at 0, now that's going to be moving down 2, so I'm going to have a horizontal asymptote right here, but my new y-intercept is left 1, down 2, which is going to be right there. So my graph is going to look something like that. That's important. My domain has not changed, so my domain in this case is still going to be -infinity to +infinity. Right? That's the set of all x values that make up the graph. And my range, though, is now going to go as low as -2 and can go all the way up to +infinity. Whew. All right, this one is, for this example, what we simply want to do is we want to rewrite our 4 as a -1, right? Or I'm sorry, our 1/4 as a 4 to the -1. So therefore, what I can technically do is rewrite this as a -4 to the -x -2. Okay, so it's really important. A lot of things going on here. We have a reflection about the x-axis, which we talked about over here. We have a reflection about our y-axis, which is going to be up here, and then we're shifting our graph 2 units down. So what we got to do is look at our original parent graph. So this is our original parent graph. Looks something like that, right? Now in this case, my graph is being reflected about the x-axis, reflected about the y-axis. So going to look like this. And then now it's going to look like that. And then I need to, so already it's down to here. So if I do my 2 reflections, it's now going to look something like that. And then I need to shift it down 2 units, right? So going from here, and then we're going to go down 2 units. So 1, 2. So now you can see my new y-intercept is going to be right here. My horizontal asymptote did not change, right? When I reflect about the x-axis, doesn't change. Reflect about the y-axis, doesn't change. But when I shift it down 2 units, that is going to be my new y-intercept. So this graph is going to look something like that. Kind of crazy, right? Let me actually graph in this other one what happened there. Okay, so, but I'm going to write everything in the domain and range in green because that's going to be our final graph here. So my domain has not changed, so that's going to be from -infinity to infinity. However, my range, though, now is going to be from -infinity all the way up to -2. So negative infinity to -2. And quick little thing, I'm actually going to go back and just draw my original graphs so you guys can see what I did there. So that's always going to be the parent graph. I always like to draw the parent graph because I think that's helpful for you guys to see how I go through my transformations. All right, this one is now, again, I have my A in front, so that's going to be a vertical stretch. So that's actually going to change my new y-intercept. So instead of at 0, 1, you can see that's going to be like at 0, 3, right? My y-intercept, or my horizontal asymptote did not change though. But now I have this x minus 2, that's going to shift the graph 2 units to the right. So now it's going to look something like that. So let's do a different color. Let's use my black. So now my new graph is going to look something like that. As far as my domain and range goes, the domain is going to be from -infinity to infinity. And my range is going to be from 0 to infinity. All right, last one. And in this case, it's always important when you're dealing with the any kind of transformations on the inside that we want to be able to rewrite this with a b factored out. So in this case, what I'm going to do is rewrite this as -x plus 1, and then I'm going to factor out the negative. So therefore, that's going to be e negative times an x minus 1. This is important because if I take my parent graph here, which is going to look like that, have a y-intercept at 0, 1, we need to understand the transformations that are going on. The y-intercept, or the reflection inside the function, is going to reflect about the y-axis. So now this graph is going to go in this format, but then it's also going to be shifted 1 unit to the right. So if we look at this, what we're simply going to do is move this graph 1 unit over here, and then it's going to look something like that. So now we can say that my domain is -infinity to infinity, and my range is going to still be the same, 0 to infinity, because again, with these transformations, ladies and gentlemen, my y-intercept has not changed, right?